Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics Class 11th. The chapter that we're dealing with is Introduction to Three-Dimensional Geometry, and now is the turn of exercise 12.2. Once again, a simple exercise which is based on the idea of distance formula. Distance formula in 2 dimensions is very simple, and in 3 dimensions is also very simple. Like in 2 dimensions, if you want to find the distance between 2 points x1, y1, comma x2, y2, then what do? We take x2 minus x1 square plus y2 minus y1 square and take the under root. That's the distance between these 2 points. Similarly, in 3 dimensions, the coordinates of any point will look like, any 2 points will look like x1, comma y1, comma z1. Another point will be x2, comma y2, comma z2. And the distance between these 2 points will be x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, and take the complete square root of this. That will be the simple formula, right? Simple extrapolation of this version, and you get the formula for distance. Other than that, some basic common sense will be applied in solving these questions over here. Like for a right angle triangle, what you can say is the length of hypotenuse square is equal to the length of other 2 sides square and added, right? That's the Pythagoras theorem, right? Similarly, for isosceles triangle, you have 2 sides of the triangle equal, right? And similar kinds of ideas. So along with the questions, we'll be seeing these ideas again, revisiting those things, and let's move on to the first question along with this. The first question says, simply find the distance between the following pairs of points. Take care of calculations. That's the only thing that you need to do. Otherwise, everything is good. So in the first question, what do we have? Let A 2, 3, 5 and B 4, 3, 1 be the 2 points, right? Then AB is equal to under root of, as I said, x2 minus x1 square. So 4 minus 2 squared plus 3 minus 3 squared plus 1 minus 5 squared is what you'll need over here, right? Now what is 4 minus 2? That is 2, and square will be 4 plus, this is 0 plus 1 minus 5 is minus 4, the square will be 16 in the under root. This is under root of 20, or if you want, you can take out a factor of 4 common, that will become 2 square root of 5. That is my answer for this question, part 1. Let's take a look at the other 3 parts one by one. In part 2, the distance, let me write it, distance will be equal to, let me write the distance directly, under root of x2 minus x1 square, which is 2 minus or minus 3, that becomes 2 plus 3 squared plus 4 minus 7 squared plus minus 1 minus 2 squared. This is 25 and this is 9 and this is 9 again. This is minus 3 squared is 9, minus 3 squared is again 9. What does this become? This is 18 plus 25 is 43, square root of 43. That's my answer for the second part. What about the next one? Let's take a look at the third part. Distance is equal to x2 minus x1. In the under root, you'll have 1 minus of minus 1, which will become 1 plus 1 and it's a square, plus minus 3 minus 3 squared plus 4 minus of minus 4 will become 4 plus 4 squared. This is what you'll get, right? So this here is 2 square, which is 4, plus minus 6 square, which is 36, plus 8 square, which is 64 in the under root. So this becomes 104 in the under root, which is also equal to, you can say 4 into 26 in the under root. So 4 under root of 4 will become 2 under root of 26 will remain. This is what you'll get. That's my answer for this third part. In the fourth part, what do we have? 2 minus 1 3 and minus 2 1 3. That's what we have. So distance will be equal to under root of minus 2 squared plus 1 minus of minus 1, which is 1 plus 1 squared plus 3 minus 3 squared. This is what you have, right? What does this become? This is minus 4 square, which will be 16, plus 2 square, which will be 4, plus 0 square, which will be 0, and this becomes square root of 20, which can be written as 2 square root of 5. 20 can be written as 4 into 5, square root of 4 is 2, this will remain. That is my answer for this fourth part. That's the complete solution of this first question, as you can see over here. In the second question, the person says, show that the points this are collinear. Okay. If 3 points are collinear, they lie on a straight line, and they follow a simple relation, that is, in this particular diagram, the length of AB plus the length of BC will be equal to the length AC for collinearity. So using distance formula, I can find the distances and I can use this condition to check whether any 3 points given are collinear or not. So let's begin with naming the points. Let A minus 2, 3, 5, comma B 1, 2, 3 and C 7, 0, minus 1 be the 3 points. And I can find the distances now. AB is equal to what? The distance AB will be square root of x2 minus x1, which is 1 minus of minus 2, which becomes 1 plus 2 squared, plus 2 minus 3 squared, plus 3 minus 5 squared. This is what you have. Is that okay? Yes. This is 3 square, which is 9, plus minus 1 square, which is 1, plus minus 2 square, which is 4. This is what you get. What does this become? This is 14, square root of 14. This is AB. What is BC? Let's find BC. The length BC will be under root of x2 minus x1, 7 minus 1 squared, plus 0 minus 2 squared, plus minus 1 minus 3 squared. What will this become? 6 square, which is 36, plus 2 square, which is 4, plus 4 square, which is 16. This is what you get. What will this be equal to? This is 56, square root of 56, and 56 can be written as 14 times 4, square root of 4 will be simply 2. So this is 2 root 14. What about the next length? AC. Can we find AC as well? Yes. Under root of x2 minus x1. So 7 minus of minus 2 is 7 plus 2 square, plus 0 minus 3 squared, plus minus 1 minus 5 squared. This is 9 square, which is 81, plus minus 3 square, which is 9, and this is minus 6 square, which is 36 in the under root. This is 90 plus 36 is 126. Now what is 126 equal to? Can we factorize 126? Yes. 126 can be divided by 9, and what will you get? 9 times 14. Now square root of 9 is 3, so this becomes 3 square root of 14. And can you observe that 2 square root of 14, 1 square root of 14 added together will be equal to 3 square root of 14. So since any two lengths sum up to, mind you, this could have been any two lengths equal to the third one. It is not necessary that AB plus BC will be equal to AC. You could have had a different arrangement, A, C, B, and you could have said AC plus BC is equal to AB. This would also work. Or for that matter, if you would have had A in the middle, C here, B here, you would have said AB plus AC will be equal to BC. So any of these are okay. Herein, obviously, we are getting the same thing. Sum of any two is equal to the third one, since AB plus BC is equal to AC. This implies that A, B, C are collinear. It's collinear points, hence proved. That's a complete proof of this question. That's all that you have in the second question. The third question says, verify the following. Okay, there are three parts of this. This are the vertices of an isosceles triangle. Then the second part we have this are the vertices of a right angle triangle. And the third part we have 1, 2, 3, 4. These are the vertices of a parallelogram. How will we go about solving this question? Let's take a look at the solution. So each and every part will be solved separately. Let's talk about the first part. This are the vertices of an isosceles triangle. So let's name the points and find the side lengths AB, BC and AC. See whether any two sides are of same length. Okay. And let's also ensure that they are not collinear. If the 3 points are not collinear, they will form a triangle, right? So for collinearity, we have seen the condition, right? AB plus BC becomes equal to AC. If something of that sort happens, then there will be an issue. But otherwise, you will get a triangle. And if you get any two sides equal, then you can say, okay, it is an isosceles triangle. So that's the common sense that I was talking about initially, right? So in the first part, you have A, which is 0, 7, minus 10. You have B, which is 1, 6, minus 6. And C, which is 4, 9, minus 6. I've just noted the points. That's all. Now let's find the distances, right? Side lengths. AB is equal to what? Under root of 1 minus 0, which is 1 squared, plus 6 minus 7, which is minus 1 square, which is 1 again. So let's write the squared terms only. I'll do is, this is the square term, right? 1 minus 0 is 1 square, which is 1. 6 minus 7 is minus 1 square, which is 1. Minus 6 minus or minus 10 becomes minus 6 plus 10, which is 4 squared will be 16. And this becomes 16, 17, 18. 18 in the under root. That is 9 times 2. 9 can be factorized as 3. This is what we'll get, right? What about BC? The side length BC, what will it be equal to? 4 minus 1, 3 squared is 9 plus 9 minus 6, which is 3 squared will be 9 plus minus 6 is gone, 0. This is what you get, which is under root of 18, which is again 3 square root of 2. What about AC? So if you see, I get AB is equal to BC is okay. Let's find AC as well to ensure that this is forming a triangle, right? Sum of two sides should be greater than third side for forming a triangle, right? So let's see. 4 minus 0, which is 4 squared is 16. 9 minus 7 is 2 squared is 4. Minus 6 minus or minus 10, which is minus 6 plus 10. What does that become? 4 squared is 16. So that's 36 in the under root. And that becomes 6. So can you see sum of these two is greater than this side? Yes, first of all. So from here, I note that AB is equal to BC. Therefore, isosceles triangle. And we already have seen that AB plus BC is greater than AC. Hence, proved. Yes or no? Yes. That's a complete proof for the first part. What about the second part? Let's take a look at the second part. Let's take a look at the second part over here. We need to prove are the vertices of a right angle triangle. Let's focus on that. So we are given A, which is 0, 7, 10. We are given B, which is minus 1, 6, 6. And we are given C, which is minus 4, 9, 6. This is what you have, right? So let's find AB. What is that? By the way, in a right angle triangle, we are looking at AB square plus BC square is equal to AC square, something of that sort, right? Sum of squares of two sides should be equal to the square of third side. AB is under root of minus 1 minus 0, which is minus 1 squared 1. 6 minus 7, which is minus 1 squared 1. 6 minus 10 is minus 4 squared, which is 16. That becomes root 18 first of all, which is 3 root 2. What about BC? BC is equal to this minus this. Minus 4 minus or minus 1 will become minus 4 plus 1, which is minus 3 squared is 9. 9 minus 6 is 3 squared is 9. 6 minus 6 is 0. This is what you get, which is square root of 18. Oh, that becomes 3 root 2. What about AC? Can you find AC as well? Yes, let's take a look at this. This, minus 4 minus 0 becomes minus 4 squared, which is 16, plus 9 minus 7, which is 2 squared, which is 4, plus 6 minus 10, which is minus 4 squared, which is 16 in the under root. This is under root of 36, which is, what is this equal to? This is equal to 6 here. Yes. Oh, we get similar side lengths here also. Yes, we are getting similar side lengths here also. Is this a right angle triangle? Let's check. So if I see that these two sides are small, yes. So AB square plus BC square since this square is equal to 18 plus 18, which is 36, and do you see that this is nothing but AC squared. So this square summed is equal to this square. Therefore, ABC is a right angled triangle. Hence proved. That is a simple proof of this second part. We take a look at this complete solution over here. Yes, that's the second part for us. Now let's move on to the third part, wherein we need to talk about a parallelogram. So one simple idea of proving that any figure is a parallelogram is this. I'll explain that first. Simple idea of proving any figure is a parallelogram. If you have this kind of a parallelogram, let's call it A, B, C, D. So one simple idea is that AB is equal to CD and AD is equal to BC. Okay. AB is equal to, you can say DC, okay, and AD equal to BC. If opposite sides are equal, then yes, you can say that the given figure will be a parallelogram. Now this condition ensures that it is a parallelogram. It may also talk about further things that if this is true, then the figure may be a rectangle as well, right? So what is the difference between a parallelogram? All parallelograms are not rectangles, but all rectangles are parallelograms. That's the first idea. A rectangle is a parallelogram, is it not? Yes, it has opposite sides parallel. But there's another special thing about rectangle. What is that? The lengths of the diagonals are also equal. In a parallelogram, the diagonals are not equal, right? So if you are given that the given figure is a parallelogram but not a rectangle, then what you will ensure is this equals to this equals to this, and the lengths of the diagonal are not equal. Here, we are not asked this. We are only asked whether a given figure can be proved to be a parallelogram. So this is enough to show that. Or there can be another approach to this. If you can find the slope, that's true for 2 dimensions, right? In 2 dimensions, we talked about the slope. So if AB is parallel to CD and AD is parallel to BC, that's what parallelogram talks about, right? The opposite sides are parallel. The 2 pairs of opposite sides are parallel. But this is true in case of 2 dimensions, yes. What about 3 dimensions? So do we have something related to slope in 3 dimensions as well? Yes, we do have something related to slope, something similar to slope in 3 dimensions, but that is not what we'll be discussing in this chapter over here in class 12th. That's there in class 12th, right? So there's another, you'll encounter this chapter again in class 12th, that will be 3-dimensional geometry, and then you'll study something called direction cosines of any line. Those are equivalent to, you can say, slope of 2D is equivalent to direction cosines of 3D in some sense, right? So is this another idea of proving a parallelogram? Yes, this is another idea. But there's another very simple idea of proving that any given figure is a parallelogram. What's that? Now parallelogram is such a unique figure for which if you draw this diagonal and if you draw this diagonal, this particular point O will actually bisect these 2 diagonals. Now this happens in parallelogram. Yes. Does it not happen in any other shape? No. Parallelogram and beyond. Yes. What am I talking about? Parallelogram and beyond means what? So from a parallelogram, let me write parallelogram, you can move in 2 directions. In parallelogram, diagonals bisect. This is true. Diagonals bisect in a parallelogram, yes. If diagonals bisect, then the figure is a parallelogram. Rest all quadrilaterals come before that, right? Trapezium, diagonals do not bisect. Kite, diagonals do not bisect. What about square, rectangle or rhombus? Yes, rhombus comes after this. Diagonals bisect. Diagonals, if they become equal as well, do you see that you get a rectangle. Form a parallelogram, you reach the level of a, what do you call a rectangle. If diagonals are equal, then what do you get? If diagonals bisect and diagonals are equal, then you get a rectangle. Mind you, this and this satisfies rectangle, right? If diagonals are equal, will the figure be a rectangle? No, I'm not saying any of that. You can get a trapezium in which diagonals will be equal, right? But it will not be a rectangle. Since the diagonals do not bisect, right? I can draw a trapezium for which diagonals will be equal. Yes, isosceles trapezium. This diagonal will be equal to this diagonal. But do these bisect? No. So if for a quadrilateral, if diagonals bisect and they are equal, then it will be a rectangle. Second, diagonals bisect and diagonals are perpendicular to each other, then the figure will be a rhombus. Then the figure will be a rhombus. Rectangle looks like this. Okay. The diagonals are equal. Rhombus, what happens in case of rhombus? Something else also happens. All the sides become equal, yes. But the diagonals, the main thing is diagonals bisect and they are perpendicular to each other. In rectangle, diagonals are not perpendicular to each other. And when we have, let's say, diagonals bisect, diagonals equal and diagonals perpendicular, when we have all three things combined, then the thing that you get is a square. Square is this. The diagonals are equal, they are perpendicular, they bisect. So diagonals bisect, equal and perpendicular implies the given figure will be a square. So from here to here, you can reach this place. From here to this place, if you add the remaining condition, you will get a square. Oh, there's another idea of proving a square. What's that? The four sides are equal. Okay, that will be rhombus. But the diagonals are also equal. That will also make it a square. There's another idea, yes. The simplest, that's what I'm talking about. If you are given the coordinates, find the midpoints of diagonals. If the midpoints are same, therefore the diagonals will bisect each other. And if the diagonals bisect each other, then you can say that the given figure is a parallelogram. If the diagonals are equal, then you can say that it is a rectangle. Also. Okay. So what about this particular question that we saw over here? In this question, do we know how to find the midpoint yet? Frankly speaking, in exercise 12.2, we haven't yet talked about the midpoint. We'll be talking about midpoint in exercise 12.3. So, using distance formula, how can you prove? So, you remember the first point over there? Yes, that's what you'll be using. Okay. This are the vertices of parallelogram. So, let's find the lengths. Okay. Now, in general, the person may actually confuse you. Let me give random vertices. But here in this particular question, we are kind of assuming, but the examiner is also clear that he has given you consistent vertices, that the vertices will be A, B, C and D. Mind you, in triangle it does not make a difference. You can go clockwise, you can go anti-clockwise or anything. But in case of four vertices, it is important in what order they are given. And in case of two dimensions, points in two dimensions, you can actually plot them easily. But in case of 3 dimensions, yes, you will find difficulty in plotting the points. There's no doubt about it. 3 dimension plotting, difficult, right? If you want, you can imagine those points, right? For example, we saw this is the XY plane, the previous session, right? This is the x-axis, this is the y-axis over here. This is the z-axis. So, what will be the point? -1, 2, 1 lie. So, z coordinate is positive, x is negative, y is positive and z is negative. So, this is, origin is somewhere here, you move back -1, you move towards positive y and then you move towards positive z. So, you reach this particular point over here. Then you get 1 minus 2, 5. What is that? You move along positive x and negative y, okay, behind this, and then you move positive z, okay, this is the point. So, you want to get one point over here, the other point over there. What is the third point? 4 minus 7, 8. Again, z is positive. So, plus 4, x-axis, y coordinate is negative and z will be somewhere here. So, 1, 2 and third point will be there. fourth point, if this comes somewhere here, will be done. 2 minus 3. So x coordinate 2, y coordinate minus 3 is what you're talking about, minus 3, and z coordinate 4 is something what you're talking about. Okay, that's also there in this particular quadrant only. Yes, that's there in that particular quadrant only. So 1, minus 1, 2 and 1 is what you're looking at. Minus 1, 2 and 1 is the point over here. Then you have another point over here, okay, and then you have the next point over there and the next point beyond that. It is difficult, yes, it is difficult to imagine, to plot these points in the three-dimensional space, because three-dimensional space is this, right? So how will we mark this point and how will we ensure this point? Frankly speaking, there is no direct approach to ensure that these are given in order, but we assume, okay, these are given in order, and now we'll be talking about whether these vertices form a parallelogram now. So we'll be assuming kind of thing. I'm clearly saying that we'll be assuming, although we can plot and ensure, okay. But let's find if the vertices A minus 1, 2, 1, comma B 1, minus 2, 5, C 4, minus 7, 8, and D 2, minus 3, 4 are the vertices in that order. Can you find the length AB, BC, CD, AD? AB will be equal to what? 1 minus 1, which will be 2 square, 4, plus 2 minus 2, which will be 4 square, 16, plus 1 minus 5 will be 4 square, 16. What's that? 16, 16, 32. 32 plus 4 is 36. Under root will be 6. This is AB for us. BC will be equal to what? 4 minus 1 is 3, square will be 9, plus minus 1 minus 2 will be 5, and square will be 25. Then you have 8 minus 5 will be 3, the square will be 9. This is what you get. 43. Square root of 43 is what I get. AB, BC, CD is what we'll be talking about next. So let's talk about that. 4 minus 2 squared is 2. Sorry, 2 squared is 4 actually. Plus minus 3 minus 1 minus 1 will be 4, squared will be 16. Plus 4 minus 8 is 4, squared will be 16. Under root, this will be 36 under root, which will be 6. AD or DA, whatever you want to call it, will be equal to what? 2 minus 1, this is 9. 5 squared is 25. And 4 minus 1 square is 3 squared, which is 9. What is that? Under root of 43. This is what you have, right? 9 plus 25 plus 9, this is under root of 43. Is that okay? Yes, that looks pretty much okay. And once you reach this stage, can you identify that these two lengths are equal? These two lengths are also equal. And that ensures AB, since AB is equal to CD and AD is equal to BC, this implies that ABCD is a parallelogram. Whether it is a rectangle or not will be ensured if you find AC and BD. So if you want AC and BD, you can find AC and BD. If they are equal, then this figure will also be a rectangle. If they are not equal, then it will be only a parallelogram, not a rectangle, right? That's all that is required in this third question over here. Yes. In the fourth question, the person says find the equation of the set of points which are equidistant from the points. Set of points which are equidistant from these points, right? So let A 1, 2, 3 be the first point, B 3, 2, minus 1 be the second point, and P x, y, z. Equation of the set of points will be in terms of x, y, and z, right? Be the required set of points, right? So PA equidistant implies PA is equal to PB, implies this particular thing implies that PA square will be equal to PB square, just so that we get rid of the square root, right? So what happens in case of PA? This is x minus 1 square plus y minus 2 square plus z minus 3 square, and it is equal to PB, which is x minus 3 square plus y minus 2 square plus z plus 1 minus 1 becomes this square, right? So what do you get? You can square them, yes, cancel some factors, and then you will get your answer. Or indirectly, what I want to do is a square minus b square. I want to bring it out there. So x minus 1 square minus of x minus 3 square, let's take a look at that over here. If you add, this is a square plus b, a square minus b square, what you'll get is a plus b, a minus b. And do you see that this will simplify as 2x minus 4, the sum of both of them. The difference will be x gets cancelled, 3 minus 1 will become 2. This is what you get. So you can do that for y terms as well, for z terms as well. And what you get is, okay, sum of these two, that becomes 2x minus 4. And this minus this, x gets cancelled, minus 1 minus or minus 3 becomes 2. Plus this will be 2y minus 4. And the difference, y minus 2 difference will be 0. Yes, the difference will be 0. Z minus 3z plus 1, 2z minus 2 is what I get. And this minus this will be minus 3 minus 1, which will become minus 4 equals 0. That's what you get. So a square minus b square can be written as a plus b, a minus b. This becomes a 0. This is 4x minus 8. This is plus 0. Minus 4 times 2 minus 8z, and minus 4 minus 2 becomes plus 8. This is equal to 0. So what does this become? This becomes 4x minus 8z equals 0, or x minus 2z equals 0. That's what you want. That's the final answer for this equation of the set of points which are equidistant from the points. This and this is what you get. And in future you will learn, if there are 2 points, let's imagine these 2 points, and any set of points which are equidistant from these 2 points will be this. What are we talking about? We are talking about a plane surface over here. So all points on that plane surface will be equidistant from these 2 points, right? Midpoint, yes. Some point away, some point away, some point away, some point away on that plane will be equidistant from these 2 points. So this actually represents a plane in 3-dimensional geometry. A plane surface in 3-dimensional geometry. This. Yes, yes. Right. This is the 4th question for us. Question number 5 says, find the equation of the set of points P, comma, the sum of whose distances from A and B is equal to 10. You want to find the set of all those points P. So let P, X, Y, Z be the given point, right? A is already known, 4, 0, 0, and B is minus 4, 0, 0. Oh, these points lie on the x-axis. One on positive x, the other on the negative x, yes. And it is given sum of the distances is equal to 10. This is given, right? Please note that. Sum of the distances from this is equal to 10. Okay. You've read something called conic sections, right? You've studied conic sections, yes. Remember, from any two fixed points, if sum of distances is fixed, then the locus of that particular point or the set of those points will form an ellipse in a plane. Mind you, in a plane, they will form an ellipse. So what will they form over here? Kind of ellipse in this plane, in the other plane, in the other plane, in the other plane. You will get a 3-dimensional shape actually, which will be kind of this. Looks like ellipse when you project it on this plane, but this will be a 3D shape, round shape. Yes, and this 3D shape, this 3-dimensional shape will be called, something called ellipsoid. Yes, you've heard cuboid, yes, right? Something of that sort, right? Cuboid is a 3-dimensional shape, similarly ellipsoid, right? This is formed from an ellipse, right? Any 2 points inside this will be focus, and sum of distances of any 2 points will be equal, right? And these points will be on a surface basically, right? That closed shape will be an ellipsoid. So let's talk about PA plus PB equal to 10 and maybe get the equation of that ellipsoid kind of thing, yes. Yes. This is going beyond your scope. Forget about this. Let's solve this question and see how we obtain the answer. PA is under root of PA is x minus 4 square squared plus y minus 0 squared plus z minus 0 squared. PB is x minus or minus 4, that becomes x plus 4 squared plus you get a y square and a z square. You see the calculations have been made simpler for you. The person could have given y and z coordinates as well. Avoid. Let's use these only. So you have two square roots on the left hand side. Should we square directly? Will unnecessarily complicate things. When you have two under roots on one side, take one of the roots on the other side and then you can square. Right. So what I'll do is, I'll leave this x minus 4 squared plus y squared plus z square on the left hand side. I'll take this 10 minus under root of over here. I'll do this. Once I have done this, now I can square. This is x minus 4 squared, this is y squared, this is z square. This is equal to, this is 10 minus something, which is a minus b form, so that will be a square plus b square minus 2 into a, which is 20, under root of this 2ab. This is what you'll get, right? And can we cancel certain terms? Yes, we can cancel certain terms. We see y square, we see z square, we see y square, we see z square, we can cancel that. Oh, there's another root remaining. So what we'll do is we'll square again, right? But first let's take everything else on the other side so that we get rid of this root easily. Okay, so we'll need some more space. Let me get rid of this whole idea over here and we can discuss after that, right? So let's talk about this one. What do we have? Okay, this remains as it is. Never mind, we can solve this over here. Bring this x plus 4 square in this way. So x minus 4 square, x plus 4 square, the difference will be a square minus b square, which can be done as sum of the two. X minus 4, x plus 4, the sum will be 2x. And the difference will be x minus 4 minus of x minus 4 will be minus 8. Okay, then you have minus 100, which will be minus 20 under root of that huge expression. Yes, and now I'll be able to square this. Yes, I'll be able to square this. This is minus 16x minus 100 and that's minus 20. So let's cancel certain factors over here. 16, 100 and 20. We can cancel a factor of 4. Yes. So that becomes minus 4x minus 25 is equal to minus 5 under root of, this becomes x plus 4 squared plus y square plus z square. Okay. And now let's continue further and see where does that take me. Let's square both sides at this stage. So 4x and 25 minus 4x minus 25 squared will become 4x plus 25 square, which is 16x square plus 625 minus, plus 25 into 4 into 2 is 100x, which is equal to square of this is 25 and then you get the remaining thing. In the bracket you will get x plus 4 square, which is x square plus 4 times 2 is 8x plus 16 plus y square plus z square. This is what you have, right? This is what you have. And what remains, let's bring everything on the right hand side. There's 25x square, 16x square, which will become 0 equals to, or you can leave that 0 later for later. Bringing everything on the right hand side, I get 9x square. Then I get 25 times 8, which is 200x. You have 100x, so that will be 100x extra. Then you have 25 times y square plus z square. This is what you'll have. And other than that, what you'll have is 25 times 16. What is that? 400 and 625. So that can remain over that there and you will get 225 over there. This is what I'll be getting. Right? Is that okay? Yes. That looks pretty much okay. 25x square minus 16x square is 9x square. 25 into 8 is 200 minus 100 is this. Then you have 25 y square, 25 z square over here. 25 into 16 will be 400 and minus 625 will be minus 225. That will remain on the right hand side. That will become 225. And this here is the final answer of the required set of points P, as you can see over here, which will be obviously part of that ellipsoid as I discussed initially. But don't worry about that ellipsoid for now. Only worry about this. That's all that is needed in this particular question, as you can see over here. Is that all? Yes. That's the end of this exercise as well. So with this we come to the conclusion of this exercise from the chapter Introduction to Three-Dimensional Geometry. Till the next session, all the best.